Okay, in your ISN, we're going to talk about two more angle congruence postulates or theorems. Today, why is this not cooperating? There we go. We're going to look at the angle side angle congruence postulate. Hopefully you understood side, 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 which is when all three pairs of sides and two triangles were congruent. The triangles were congruent. SAS, two sides and the included angle. Now it's going to be an angle and a side and an angle, which means it's two angles and the included side. So that would be the side between the two congruent angles. Okay? The side between the two congruent angles. So if two angles on the included side of one triangle are congruent to two angles on the included side of a second triangle, then the two triangles are congruent. In this picture, we have a single arc mark on angle A. That would correspond to the single arc mark on angle D in the other triangle. So angle A is congruent to angle D. Side AC has a single slash on it, and it's matching up with side DF in the other triangle that has a single slash on it. Angle C has a double arc mark on it, and so does angle F in the other triangle. So angle C is congruent to angle F. Those are the corresponding parts. Now, we're going to name the triangle congruence. What we see here is an angle, then a side, then an angle. You always got to go the shortest way to get to the next marked part. You can't go jumping around like that. I can't go angle, then an angle, then a side. You went too far and skipped too many parts. You got to stay where they're clustered more together. Okay? So that's why it's an angle, side, and an angle. So triangle ABC now, that's giving me a direction of the letters in order to name the congruence. So if I go from A to B, what corresponds to going from A to B in the other triangle? From, D to E. Okay, so it'd have to start out triangle DE, and then of course there's only one letter left. You go from B and you round the corner, go down to C. So on the other triangle, that'd be going from E to F. So it's DEF. Okay, and they are congruent by angle, side, angle. The other one today is angle, angle, side. Now it's going to be two angles and a non-included side. Okay, the side is not between the angles. The congruent angles, by the way. So it's not going to be between the congruent angles. So what we got here in this diagram, if two angles and the non-included side of one triangle are congruent to two angles and the corresponding non-included side in the second triangle, then the two triangles are congruent. So it does have to correspond properly. Angle A has a single arc mark. So does D. It's the same setup as the other diagram. Angle A is congruent to angle D. Angle C, double arc on angle F. Angle C congruent to angle F. And side BC has a single slash on it, and it's corresponding to side EF. Since BC and EF do correspond properly, and you have two angles marked congruent, then triangle ABC, again, is congruent to triangle DEF. But this time, it's by an angle, then a side. Maybe this would help. If you like to put these letters on there, I'll show you that on both of the diagrams. So an angle, then a side, angle, angle, side. On the previous one, it went angle, then a side, then an angle. Angle, then a side, then an angle in both triangles. Okay, so this was the first one. This was the second one. Do you see the difference, I hope? Okay, it's real important that we see the difference between the two. Okay. Anybody still need this? No? Okay, no one said yes, so now we're going to practice. Which theorem or postulate could be used? Okay, so far we've had side, 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 and side, angle, side. That was yesterday. Today, we just talked about ASA and AAS. There are two things that we already know we can't. Remember, there is no ASS theorem, okay? Or there's also no angle theorem, which I'm going to discuss with you today a little bit, okay? There's no, and I'm sorry, I guess that would be better if I didn't write that this way. Maybe I should write it backwards so that it doesn't look like I'm writing foul words on my paper. So no SSA or donkey, okay? So never will you ever use either of those. So let's go on to what we can do. So in this diagram, when you look at this, I hope you're seeing that AC is a side, okay, that corresponds to DF. BC is a side that corresponds to EF, and then there's an angle, C and F, between the sides that match each other in markings. So this would be SAS, correct. A side, an angle, and a side. The next one's an example of an angle. See the two angles that they match up, and then a side between the angles. So this is angle, side, angle. On the next one, I'm going horizontally. The shared side can always be marked congruent to itself. So you got to mark that. Then what do we have? We have an angle, actually in another angle, two sets of angles, and a pair of a side that's between the angles. So this is another ASA. Isn't the next one also? Yep, we got a shared side between them. You have an angle and an angle, an angle and an angle, and the side smushed between the angles. Another ASA. Wow, that's a lot of ASAs in a row. Okay, I don't know why we didn't have any AASs, but we didn't. This one, shared side in the middle. All of those, there aren't any angles marked. So what's the alternative? All the sides are marked, so side, side, side. Now, I'm going to challenge some of you, like on the next one. The first thing I see is single mark, double mark, triple mark. So this means SSS applies. But is there another one we could use? Is there anything else in the picture you could mark congruent because it's fact that it is congruent? Emily? Vertical. Kenny said it. Carolyn, I heard you guys. Thank you. Yep, you could mark these vertical angles congruent, which would be, let us do what other one? Side, angle, side. I heard somebody. So you could do SAS. But let me just say this. You should mark it on your picture if you're going to use it. Okay? You got to mark up the diagram. All right, and then this last one, that's all we can do is side, angle, side. Okay? That's it for the ISM. So let's head over to the worksheets that we got, the packet. We're going to do a lot of it together. Okay, I'm going to re-talk now about angle, side, angle. If two angles in the included side of one triangle, again, are congruent to two angles in the included side of a second, then the two triangles are congruent. Say I put an angle marked here, and this angle would correspond to it. So say those two are congruent. And then I went and said this top angle is congruent to this angle on the bottom of this triangle because it's flipped over. Now, I want it to be an angle, side, angle. So there's a specific place I need to mark the sides. Where would it have to be? The side that is a segment which is between or included between the angles. So that would be here on this triangle and over here on that triangle. Okay, now that represents ASA. Okay, now let's see the difference between that. Well, let's do a proof first. We're going to prove these triangles are congruent. Okay. We are given that AB is parallel to CD. It's in the proof, and that's given. It's already been marked with the arrows in the diagram. But I'm thinking, I know I'm going to want to use that information. So I'm going to highlight it so I don't forget. Is there a transversal in here? What is it? DB? Okay. Do you see the Z now? That might come in handy during the proof. All right, so I'm going to go on now and just look at what's in the proof. All right, we messed around. We saw AB parallel to BC, or CD, excuse me. Now it says angle CBD, and that's another given. And if I got to find them, CBD is up here, is congruent to angle ADV. Now that has nothing to do with my green lines because these aren't highlighted here and here. So that's just simply something that they gave us, given. But this next line is telling me some more angles that are congruent, and I don't have any verticals up there, and it's not given, so I got to have a new reason. Angle ABD is up here. Angle BDC is down here. Now they have to do with my parallel lines and transversal. Why are those angles congruent? Okay, I see Daryl's chomping at the bit. I know you're really on it. 1 second, guys. Come on. Olivia, I think you got enough on now. Let's think about this. We got some parallel lines cut by a transversal. What kind of angles are these? So you okay? There's some noises coming. All right, these guys, what are they? This is from another chapter. Go ahead, say it, Evan. Are they on the outside or inside between the lines, the parallel lines? All right, they're on the inside, and they are switching sides of the transversal, so they are alternate interior angles. So parallel lines implies you've got alternate interior angles congruent. Now, this is what I preferred you write, but if you wrote the alternate interior angles theorem, that is correct, because that's what it says. If parallel lines, alternate interior angles, you got to remember this stuff, guys, for these proofs. You have to remember previous things from other chapters. So we're applying the fact that we knew something about parallel lines. It could be angles are corresponding in some proof that we do. Okay, could be alternate exteriors. I don't know. All right, now, BD is congruent to itself, which is right here, that segment that's shared. What is the property that allows us to say something's congruent to itself? Say it louder, Bryce. Reflexive. I heard you too, Penny. I'm acknowledging that you guys are saying it. That's great. Now we have a triangle congruent statement here. But we got to have a good reason for saying the triangles are congruent. So it's got to be one of our theorems. So we got to go, okay, let me just say this. I forgot to say this. If you haven't been marking your picture like I have, you will literally not be able to do this stuff. You have to have markings on your picture because that's what shows you which theorem it is or postulate. Okay, if you do not mark your pictures and you just, forget about it. It won't work. Okay, so you need the arc marks on them when you say stuff in here. I didn't do that for my fun. So if I look at this triangle, what parts do I see marked congruent? I see an angle, I see another angle, and I see the side That's between them. And it's the same up here. It's an angle and a side and an angle. So that's your reason for the triangles being congruent. Now, how many of you already wrote ASA down before I did, I hope? Some of you at least? Okay. That's angle, side, angle. All right, let's try another. We got given angle S congruent to angle V. So I'm going to go to the picture. Please do this. When you write something down about a part, go to your diagram and mark it. So I'm going to put a little arc on angle S and a little arc on angle V. All right, now I'm done with that given. Next, I'm going to go to the next given and put it in my proof. T is midpoint. I'm going to abbreviate that MIDPT of SV. You don't even have to write S of if you want. If T is the midpoint of SV, okay, what does that tell me? Well, first of all, this was given, but what is that going to tell me I could make up, I could write down? What does a midpoint do to a segment? Separates it into what? Halves. Two pieces that are equal in measure. All right, so what are those pieces? They happen to be sides of these triangles, which ST and VT. Okay, so I'm going to put that down. Segment ST is congruent to segment VT. Or you could have used no bars and said they were equal. I don't really care. It's going to work out for us. We got two segments that are equal, which are sides of the triangle. All right, why was this able to be said? That's right, you got a midpoint right there. Definition of midpoint. Okay, now I've run out of givens, and I've used the information I can use. I can't assume that T is the midpoint of RU. I can't do that. Don't ever do that. It didn't say that. It only said T was the midpoint of SV. So I got to go to this picture, and sort of like the crime scene. When they don't know what happened, they go to the crime scene and barrier it off to look for more what? Clues, evidence, etc. All right? Broken glass, blood, whatever. So we're looking for parts of triangles, which isn't quite as interesting. But when you look at this picture, is there something we could say about it? No parallel lines up here, but I do have something going on here. What are these? All right, let's mark them congruent and put them in our proof. Okay, so we need to write it correctly. So let's say we say RTS, angle RTS. You need 3 letters to name those angles. Angle RTS is congruent to angle UTV. Because they are vertical, so you write vertical angles are congruent. You can just write vertical angles congruent. You don't just write vertical angles. You should write that they're congruent. Okay? Well, now that I have marked up my picture, I can see that I'm ready to prove something. I'm ready to prove what they wanted me to prove, which is stated right here. This should be the last thing in my proof. Triangle RTS is congruent to triangle UTV. Why? Well, it's all over my picture. Is it, all right, is it side, angle, side? Is it angle, angle, side, angle, or SSS? Angle, side, okay, angle. It is 2 angles and the side smushed between them. Okay, I hope you understood that. I tried to make it where you would, obviously. The marking of the diagram is pretty critical. All right, now we're going to angle, AAS, angle, side. So let me start off this one by saying, if that angle is congruent to this one, And this angle, I'm going to do it just like I did that other one. This angle is congruent to this one. It's upside down. It's got to be a corresponding non-included side. So I need to mark a side, a pair of sides. It doesn't matter which one, but it can't be one. It can't be here. Okay, cannot be there. So you tell me, should I do it on the right or the bottom? All right, the right. So you're picking for me, and I'm doing this on purpose because it could be either one of those. So if you pick this one to show it right now, what corresponds properly to that side on the other diagram? Is it up here or down here? Okay, so it has to be on the same page, meaning this has a double arc, this side has the double arc touching it, it'd have to be there. Okay, that's what it means by it has to be the right corresponding non-included side. So if this had been marked here and that up here, this wouldn't have worked. Okay, these guys have to be corresponding properly. All right, so that's just an example, guys, of angle, angle, side. Okay, so here's another concept about that. Meaning, I might ask you a question like, okay, given this picture, what can you say? Well, you got a shared side. So AC is congruent to AC by the reflexive property. It says in this diagram that BCA was congruent to DCA, which was already marked for us. Which sides are congruent? All right, then we found out AC is congruent to AC by reflexive. Now, what additional pair of sides would be able to make us be able to use the angle side? Oh no, what additional pair of corresponding parts needs to be congruent for the triangles to be congruent? Well, I've already got a side. I already got a pair of angles. I need another what? I need another angle. Okay, so I've already got one of the sides. I've already got an angle, but I need another angle. So the congruent angles can't be 1 and 2. How come? It'd be ASA. Okay, the side would be between them. It can't touch this. It's got to be away from it. Can't touch this. Yep, the Heimer time. Can't touch this. Terrible. All right. The reason it can't be angle 1 and 2 is because segment AC would be the included side. So it's got to be angles B and D. Okay, so angle B is congruent to angle D. Then the triangles would be congruent by angle, angle, side. Okay, hope that made sense. Try something else. Can the triangles be proven congruent by the information given in the diagram? Well, we're going to start right off with something that is a no. I can mark the vertical angles, but does that mean those triangles have to be the same size just because their angles are the same size? There is no angle, angle, angle. And I'm going to give you another explanation as to why. If I made, I'll even do some shapes from up here. Okay, so if I have a triangle, can I make another triangle like that triangle that has the same size angles, but doesn't have the same size sides? I could keep going. Still the same dang shape, isn't it? But the sides are not the same size. So just like if you have an equilateral triangle, I mean, I can do this for a lot of them, all right? So let's say it's equilateral. I can make another equilateral triangle that's a lot bigger. It still has the same size angles, but the sides are not the same size, okay? So they're similar, not congruent. All right, so that's why there's no angle, angle, angle. All right, so let's move on to one we can do. This has a shared side. We've got to mark it. And now I've got two angles and a side. So this would be Yes, they can. And it would be by angle, angle, side. Two angles and a side that's not between them. Number 6, you can mark the vertical angles congruent to one another. And you need to. So yes, these triangles can be proven congruent, and it would be by angle, side, angle, because the side is between the angles. It's the included side between the angles. Okay. Let's try another proof. I've got some more parallel lines. Uh-oh. I'm going to highlight my parallel lines. It says BC is parallel to EF. Is there a transversal? You can't find a transversal that cuts through those lines? Is there a big long line that cuts through them? And that would be right here, wouldn't it? Okay. All right, so paying attention to that for later purposes. Oh my goodness, they put all of the givens on one line. So we got to get busy and mark the picture up. BC is already marked parallel to EF. AB is equal to ED. I need to put a slash on AB and ED. Angle C is said to be congruent to angle F. All right, now I have highlighted the parallel lines. I'm out of givens. Can you look at this diagram and tell me some angles that would be congruent because of the parallel lines? Where are they? It's got to be made by the green lines. Here? Is that what you mean? What would you have to call this angle, though? ABC. Okay, angle ABC is congruent to angle DEF. And why? Well, it's because I had parallel lines. But what kind are these? You remember the words? Corresponding. They're in the same spot. Corresponding. So if you have parallel lines, parallel implies corresponding angles congruent. So we still got to know stuff from the other chapter. Okay, now by our marking, since we diligently marked our diagram, let's hope, which theorem is making my triangles congruent? Both of them have two angles and a side that's not in between. So ignore that arrow because that's about parallelness. This is an angle and a side. If you write side, angle, angle, it's not wrong. Okay, if that's how you see it. But the theorem usually says angle, angle, side. Okay, next is just a summary. You may write what you need to write in the boxes here. You already have angle, side angle, which you should know is abbreviated ASA. If I could get my pointer to work for me. It's not doing its thing. What's going on? How weird. Oh, there it is. Well, usually the little thing opens up. And you guys have a nice picture of that. Sorry. Oh, yeah, she had it early out. What is going on? This is a pointer. Oh my goodness. This has not happened before. I did this the third time today and it worked fine. Okay, maybe if you can't do it with the crayon, then it wants to write. Well, I know what to write in these things. I just don't understand why my thing's not working. All right, see, I'm going to go back. Say, try it again. Pretend it didn't happen. Weird. Oh, there he goes. Okay, that's your picture, and what this thing says is, if two angles on the included side are congruent on two triangles, then the two triangles are congruent. Whatever you need to write is all what you need to write. If you're happy with the picture, just so long as you know what an included side means, that's great. I don't want to just keep reading it, but this is awful quiet. Very nice. All right, so again, angle, side, angle. If two angles in the included side are congruent on two triangles, then the two triangles are congruent. The next one is angle, angle, side. And you have a picture that shows a good diagram of that possible situation. And what that one says is that if two angles in the non-included side are congruent on two triangles, then the two triangles are congruent. Okay, might need to wait still a minute. You have all these pictures. Your next one is a picture of a right triangle, which you should know the legs, and the parts are H and L, hypotenuse and leg. That's the abbreviation for hypotenuse and leg. The hypotenuse is the side opposite the right angle, which means across from the right angle, or it's the longest side is another thing. And the legs are the sides that form the right angle. Should I wait a little bit here? I know some of you don't need some time. And you already had the diagrams labeled, right? Okay. Now, I did not go over the hypotenuse leg congruence. It will be a fifth way to prove triangles congruent. Get away from me. What is that? I don't even know why that's there. The hypotenuse leg congruence might look something like this. Now, notice that that's an angle and a side and a side, which spells a bad word. This is the only ASS that works. Why? It only works for right triangles. Okay, it has to be a right triangle. So we do not call it angle side side, we call it HL, hypotenuse leg. If you have a right triangle, and if it's going to have a hypotenuse and a leg, it's got to be a right triangle in the first place, okay? Then if one leg and the hypotenuse are congruent in two right triangles, if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the two triangles are congruent. We will study that one further, probably not tomorrow, but probably the next day, maybe tomorrow. Okay, so it's got to be the hypotenuse and a leg. I know there's one more space there. Okay, does anybody still need this though? Okay, I'll wait. Okay, anybody still need it? Okay. Some of us write faster than others. It's okay. You should kind of know what's coming next. We already talked about the next one. Okay, I can always go back. This is just the whole big thing again, except the last one is the one I need to do. All right. Corresponding parts of congruent triangles are congruent is C. Oops, C. But get a pen, Heimer. CP, CT, C. Okay, CPCTC stands for corresponding parts of congruent triangles are congruent. That would be that if 3 pair of sides and 3 pairs of angles are congruent in 2 triangles, then the triangles are congruent. Now, I got to be honest with you. We're never going to go through and put all the parts, okay? What we're going to do is, once we've proven triangles congruent by one of our 5 ways, which are going to be SSS, SAS, AAS, ASA, and HL, after that, we can say the rest of their parts are congruent by CPCTC. So it will actually come at the end of proofs, when we're not just proving that the triangles are congruent. Okay, so we got that done, okay? All right, now, name the triangle congruence postulate you can use to prove each pair of triangles congruent, then state the triangle congruence. What that means is, first thing we're do is say, oh, wow, I got 2 pair of sides, I got, oh, another pair of sides, I have actually 3 sets of sides congruent, so this is definitely congruent triangles. So let's state them. Someone give me a way to name this triangle right here. AEB. No, you got the theorem. Triangle AEB is congruent. Now, because you led me to say AEB, I have to do the proper correspondence on the other. It would be CDB. And then the reason the triangles are congruent is by side, side, side. Okay, so let's try 10. Someone name me the left-hand triangle. Any way you want. Pop. Well, thank you for someone at least doing it. Oh, you went to the right-hand side one. It doesn't matter. MNQ. Okay. Then that would be congruent to triangle. If you started with M and went to N and then to Q, on the other triangle you'd have to start with O and then go to N and then P. O, N, P. Now, these aren't the only ways to write this. But what is the reason that we can say they're congruent? And what I see by the markings is a side and an angle and a side. SAS. I hope you're seeing side and an angle and a side on both triangles. This was a side, side, side. Okay. Why? Okay, somebody shout me out a triangle congruence statement. Yes? Please give me the left triangle. PRQ? That's what I heard you say. I hope that's right. Okay, now I need to know how to write the other side. Who wants to volunteer to get this in the right order? PRQ would have to be, this one's a tough one. All right, good job. BUT. I'm hearing it from multiple people. Okay, because it's turned here. P to R has a single arc on the angle at angle P. And then it went to R, which has a single slash. So that matches up with V going to U. So this matched with this on that triangle. So it had to be VUT. Okay. And that would be by 2 angles on a side, not between them. Oh, AAS. Okay. Correct. All right, and finally, the shared side here can be marked congruent to itself. So this will be a quick one. Well, what are we going to name the triangles? JMK Nippon. Okay. Triangle JMK. Now, if I go J to M, I have to go L to M, and then up to K. Okay, so it'd be LMK. And that would be by side, side, side. Okay, I'd like you to try or do these two and work on that last page. Keep in mind the only ideas that will work for you are the ones you put to work. So, understanding. This is just an example, guys, to help you know what this wording means. You are going to go to some pictures and you're going to say, when it says the side opposite something, this is on the last page, what does that mean? A side, of course, is going to be a segment, all right? What side is across or opposite angle P? AL. Okay, so that would be segment AL. What's the angle included by AP and LA? Well, it's up here, angle A. So that's the kind of questions you're answering on this page. You need to finish the packet. And I'm going to see what questions you might have before I collect some of these packets this week.